Today, we are diving into a topic that's often overlooked but absolutely essential in the world of coding: testing. Testing is an essential part of programming and software engineering. It helps to ensure that the code is correct, reliable, and efficient. Testing also helps to find and fix errors, bugs, and vulnerabilities that may compromise the functionality, security, or performance of the software. Testing can be done at different levels of abstraction, from individual units of code to entire systems or applications. However, at our levels, we will be focusing on testing individual units of code, and more specifically, functions that we have implemented. One of the aspects of testing that is relevant for software design and implementation is the concept of test-driven development, TDD. TDD is a methodology that involves writing tests before writing the actual code. The test defines the expected behavior and output of the code and serve as a guide for the development process. The code is then written to pass the test and refactored as needed to improve its quality and readability. TDD helps to ensure that the code meets the requirement and specification and that it is easy to maintain and modify. A simple technique that a novice programmer can use for testing is the assert statement in Python. The assert statement checks if a given condition is true and raises an assertion error if it is false. The assert statement can be used to verify that the input, output, or intermediate value of a function or a program are correct, or that certain invariant or preconditions are satisfied. For example, the following code uses assert statement to test a function that calculates the factorial of a positive integer. In this example, the second line of code tests if the function's precondition is true, that is, the argument provided is positive. The assert statement after the function definition checks the postcondition of the function, that is, the returned value is the factorial of the argument. The assert statement will raise an assertion error if any of the conditions are false, indicating that there is an error in the code or the input. The assert statement can also take an optional second argument that provides a message to explain why the assertion failed. The assert statement is a useful tool for testing, but it has some limitations. It can only check for simple conditions, and it does not provide a comprehensive report of the test results. It also stops the execution of the program when an assertion fails, which may not be desirable in some cases. For more advanced testing, Python provides a module called Unit Test that supports automated testing with more features and flexibility. Unit Test allows writing the test case as classes that inherit from unittest.testcases and using various methods to check for different types of assertions, such as assert true, assert false, assert equal, assert not equal. Unit Test also provides a test runner that can run all the test cases in a module or package and generate a detailed report of the test outcomes, such as passed, failed, skipped, or errored. The use of unit test is the subject of another video. In conclusion, testing is not an afterthought but a crucial aspect of programming. It ensures your software reliability, saves time, and enhances your code's quality. Testing can also improve the design and implementation of the software by making it clearer, more concise, and consistent. Testing is a vital skill for any programmer or software engineers. And as a novice programmer, start with the simple yet effective assert statement. As you progress, consider exploring the power of unit tests for more comprehensive testing. Remember, In the world of coding, testing isn't just about finding errors, it's about building robust, dependable software. Thank you for watching and see you in the next video.